Hello everyone. Given that you already performed the lab with the app and get the satellite circling around Earth and took the video, you just have to do is put the video on the Instagram or YouTube and insert a link here. Okay, and I hope you can get even to insert a link here, like make a link. You know how to make a link. And now here I give you some hint about the questions. So question number 1, gravitational attractive force is proportional to the products of the two masses of the two objects, which means the larger the masses, the stronger the attractive force at a fixed distance. Number 2, gravitational attractive force is inversely proportional to the distance between the two objects squared. In other words, if the distance is large, the attractive force becomes weaker. Okay, that's intuitive. The third question actually is the same question but said in another way. The farther away from the center of the Earth, okay, and the gravitational force is weaker, the gravitational force. And of course, normally the distance scale is large. Looks like if you hold a dumbbell or basketball near Earth, you feel that the force is the same because they just move too little distance up and down. But they really go up really high, and the attractive force is really weaker. That's why you have to go like 15 miles, 30 miles above. And so, number 4, what is the value of gravitational constant G? That G goes into the universal gravitational formula, okay? And that G, you don't have to really remember the number, but this number is listed in almost all the physics books, and it's definitely in our textbook. But you just have to remember it is a very small number using the regular units. So that makes the attractive force between any two objects, such as a soccer ball and a cup, and their attraction, even though absolutely speaking they exist, but after multiplying by this constant, they become negligible. The gravitational attractive force only makes significant sense if one of the masses is really big, as the Earth itself. So this number. Okay, number 5, an ellipse of some orbiting object. In fact, all the travelers or planets circling around the center with some elliptic orbit. So this orbit can be described by this kind of equations. We call it parametric equation. Parametric means a parameter, or actually control parameter. Here it is a t in units of days. So in other words, the x-coordinates and the y-coordinates are changing as a function of time. So all you have to do, I want you to plot the orbit, the trajectory. So first you get a list of time, and then at each time you have x, y coordinates, and then you can plot the coordinates. For example, at 0, and you will be at 0, and then you will have this, okay, and then equal 2. So then you have to set 2 cosine and 0. Set your calculator to radians. Once again, set your calculator input setting to radians, not degrees. Otherwise, you get the real weird numbers. So then you get 2. And y 0 at 0. Therefore, for the first point, you have 2, 0. And which is actually a point here on this chart on the right. So the first point here, okay, and that's this one. And then you do one more point, So then you have x equal 0.1, which means 10% of a day. So then you get x coordinate object is at 0.1, 2 cosine 2 pi times 0.1. And then that give you the calculator. Once again, everything is in radians, and then you have the resulting location of x location of kilomiles 1.62. And the y coordinate is go up a little bit, and 2 times sine 2 pi times 0.1, and you get 0.58. So then you enter this 1.62, 0.58. So you carefully put this second point here, which is this. And now let's do one more point. Okay, and one more point. Let me do this. So x 0.2, okay, and 2.2 cosine 2 times pi times 0.2 into your calculator, and I got 1.2 roughly. Okay, I'm not sure. Make sure you get, I guess, because I'm so good. I just guess it is 1, and then 0.2. So then this formula sine 2 pi 0.02, and then you get, okay, and 0.8, say you get that. Okay, approximately get your number. Okay, and that's what I'm guessing. So therefore you get another point, and then you get this. So where it is, so they will have into the table 1.2, and then the other 0.8, and the 1.2 is, so now, okay, the other side actually from this, and that second point, and then the third point is 1.2, 0.8, so 0.9 is this. So alright, so sorry, there's a mistake. The first 3 points are these two. I remove this point and remove this point. So its first one is 2, so the first one is here. Let me change the color. The first one is this one, the second one is here, and third one is 0.2, 0.8, third one. And then I will let you to finish what's 0.3, and so what that, and then 0.3, what is that, and then I bet it will be somewhere here, and so on. Immediately it will have a circle like this, and so the point of this is to illustrate that, and all the scientists or astronomers, space scientists, well, that's the basics they understand. So the x and y coordinates is controlled by time, and they all controlled by some of the sine and cosine functions. And you sine and cosine function, you need to set yours to radians. So that's the basic of the science. If you later are going to pursue a career in engineering, especially science, and you know, the elliptical orbit is described by, can be described by parametric equations, as both x and y are functions of t. Alright, thank you for watching. I will see you in the real soon. Bye bye.